Welcome to College Algebra. In this lecture video, we are going to talk a little bit about how to solve our exponential and logarithmic equations. We've been solving some exponential equation before in other sections of chapter 5. Those exponential problems we solved before were pretty simple, okay, because those problems we were able to make the base the same, so we can set the exponent equal to each other. All right. So remember now the other type of property we already introduced, base exponent properties. We can use this technique in this section when we see the problem that allow us to do so. I can also use another technique. I believe it's in 5.3, where when we solve log equations, we can convert our logarithm into an exponential equations and solve it from that perspective. All right. So it really depends on the problem. There are certain things, certain properties that we learn will help us out in this particular sections. Another property I want to introduce is this thing called the property of a logarithmic equality. If I have a log with the base a of n that is equal to the same log with the same base of n, when the logarithm are equal and the base are the same, we can set what they are of equal to each other. And the reason is because we can actually change logarithm into exponential, so whatever they are of will actually be exactly the same. Okay, so this is another property we can use in section 5.5, where it will help us, okay, solving these equations. All right, so some of the basic idea solving exponential and log equations. For the exponential equation, try to make the base the same. If I cannot make the base the same, we can take a log on both sides. All right, I'll show you what happens here in a minute. Any equation involving with the e, we can take a natural log on both sides because we cannot make those base the same. And for other log equations, we can use property we learned from 5.4. okay, these properties can actually help me to solve some of these log equations. All right, so let's check it out, the exponential equation. So these problems are a little bit different than the one we done before. I think it's back in 5.2. For example, okay, I got 9 to the 4 over x equal to 56. There's no way I can make 56 into a base 9 or make 56 into a base 3, because 9 can be expressed as 3 squared. So what do I do? What do I do if I cannot make the base the same? Well, since this equation only got 2 terms, what I can do is take a logarithm on both sides. And student asks, why, Mr. Chen, why do we need to take a log on both sides? And the reason is this: the exponent, the variable is on the exponent. Remember back in 5.4, the log of powers, a log with any type of base a of m to the p power, okay, those exponents, when we take a log, those exponents actually come to the front. So I can use that same technique here. If I take a log with the base 10 of 9 to the 4 over x, then this exponent 4 over x can actually come to the front. In other words, I'm bring my variable down from the exponent. So I get 4 over x times log of 9. That is equal to log of 56. So I still got 2 terms because this is multiplication. So I got 4 over x. My x is in the denominator, so what I can do is multiply both terms by x, because in that case, I'm gonna put it right here in the front. In that case, it will bring my variable x to the numerator. So the x over x cancels out. What I got here is 4 times log of 9 equal to x times log of 56. Alright, so I'm not too quick putting the log of 9 in the calculator because it gives me a pretty weird looking decimal answer. So what I'm going to do here is write out the exact answer, which to get x by itself, I will divide both sides by log of 56. You know what? Yeah, let me write it out for you. So my answer, x, is going to equal to 4 times log of 9. Just in case if the homework is asking for the exact answer, this is what it looked like. Over log of 56. Alright, if we evaluate what this answer really is, now we can put it in the calculator. 2 decimal place, if the homework asks for it. The numerator is 1 term, so I'm just gonna put my numerator in the parenthesis just in case. I know it's only 1 term, but I want the calculator to do 4 times log of 9 first. Close parenthesis for the 9, close parenthesis for the numerator. Divide by log of 56. 2 decimal place, my answer about 2.18. Okay, that's how we do this problem. So if I cannot make the base the same, I can take a log on both sides to bring the variable from the exponent down. Alright. Same thing with this one. 1009 cannot be the same base as 7, so we will take a log on both sides again. So that will allow me to bring my 2x minus 8, my whole entire exponent, down. So I should have 2x minus 8. Okay, this is 2 terms. Both of them will multiply the log of 7 equal to log of 1009. Now I'm not gonna start doing distribution because that will make all these decimal way too ugly. So what I'm gonna do, since I only got 2 terms at the moment, I'm gonna divide both sides by the log of 7, so I can isolate this as 2x minus 8. Well, if I divide, then what I should have here is 1. A 1 do a distribution will isolate a 2x minus 8. So divide both sides by log of 7, so I should get 2x minus 8 equal to log of 1009 over log of 7. Alright. So now move the negative a over, and then that will give me 2x equal to all this. Excuse me. All this plus 8. And now I will just divide both sides by 2 to get x by itself. So basically what I want the calculator to do is figure out this numerator first before you get divided by 2. So it's a bit tricky how we actually enter this in the calculator. Okay, so check it out. I got 2 terms on top, so I will start out with the parenthesis. Now in my parenthesis I will start out with the log. Log give me a parenthesis 1009, close it, then divide it by log of 7, close the parenthesis for log of 7, close the parenthesis for my entire numerator, then plus 8. Oh, sorry, I closed one too soon. I actually need to insert another one. I need to insert one just for the log of 109 divided by 1009 divided by log of 7. So I'm gonna insert one for my numerator. Okay. Insert one for my numerator. Insert an open parenthesis for my first term of my numerator. Okay. So I will close it twice right here. And I will close it again for my entire numerator. So this one is associated with the whole entire numerator. This close parenthesis is for the first term. Then divided by 2. My answer, 2 decimal place, 5.78. Okay, that's how we do it. Now, if you don't want to type in everything all at one time, you will need to at least figure out the numerator first before you divide it by 2, okay? Alright, this one, 144 can become a base 12. So this is going to be... So if I can make the base the same, I'm going to make the base the same. So this is going to be 12 to the second power as for 144, but I'm still need to multiply the 4x minus 6. So once the base are the same and the base are equal, I can set the exponent equal to each other. So as I'm writing at my exponent equal to each other, I'm going to do my distribution at the same time. So that's going to be 9x minus 9 equal to ax minus 12. So move the ax over, give me a positive 1x, move the negative 9 over, that becomes negative 3. Negative 12 plus 9, negative 3. So that's my answer. Alright, I'm going to do this one right here, because this one is a little bit different than this one. Alright, still 2 terms. All these problems so far is 2 terms, okay? So if I cannot make the base the same, I take a log on both sides. If I can make the base the same, we make the base the same and set the exponent equal. Now there's no way we can change 45 into a base e. So for me to get rid of the e, what we can do is take a natural log on both sides. Because as we can recall, natural log and e kind of what? Cancel each other out. So the only thing I got with is my exponent. Excuse me. Is my exponent, negative x plus 11, equal to the natural log of 45. Alright. So I'm going to move my negative x over to this side. And move my natural log 45 over. So that'll be 11 minus natural log of 45. Alright, that will be the exact answer. Now if I want to... If the homework asking for decimal answers, we will put it in the calculator. 2 decimal place, 11 minus natural log of 45. It will be about 7.19. Alright. Now this one is a little bit different because on this side though, this is just a base 45. It's just a 45 when I take a natural log. But here, I still use the same approach. Take a natural log on both sides, because natural and e will cancel out. But what happens here, when I take a natural log over there, remember now, natural log is the same as a logarithm. It's just with a different base. So that means I can use the log of power again. That means the exponent that contains my variable will go to the front. That will be 2x over 3 times natural log of 4. Okay. Alright, now this whole right hand side is one term. The left side got 2 terms. So right now, I got 3x is a variable term. This is a variable term. Okay, but this variable term attached with a nasty natural log of 4. So what I want to do for a moment, and there are different ways we can do this, is get rid of this fraction first by multiplying all 3 terms by 3. Okay, or multiply 3 on both sides. But I want to do a distribution so I can see a 9x plus 33. I want to keep it as 3 terms. Now this side, the 3 cancels out, so that would just leave me with 2x times natural log of 4. Alright, remember now this is still 1 term. Okay, so this term contains a variable x, so I will move this term over here. Move the positive 3 to the other side, because I want to get my variable term by itself. So that will be 9x, still 9x, positive 2x times natural log of 4 come over here, become negative 2x times natural log of 4 equals positive 33 go over, become negative 33. Alright, so now I got my variable term together. They are not quite like terms, so, well, they are like terms, you know, it's just involving with nasty decimal here. So what I'm going to do here is factor out an x. Okay, if I factor out an x, that will leave me with 9 minus 2 times natural log of 4. So what that does is the 9 minus 2 times natural log of 4 becomes a coefficient. Okay, because this is still a variable term. This is the coefficient, this is my variable. So to get my x by itself, we will divide both sides by my coefficient. And factoring also makes these 2 terms on the left side into 1 term. So I will be able to divide both sides by the coefficient. Okay, pretty nifty. I think I showed y'all how to do this one time before, where if you don't have any like terms, you know, if the 2 variable terms are not like terms, somehow what you can do is factor out the variable you're solving for, okay, and then divide the coefficient on both sides. Even though these 2 terms are like terms, I'm not going to combine them. This is real nasty. 2 times natural log of 4 subtracted by 9 is real nasty. I mean, you can do it. You just gotta, you know, be a little bit careful how you put in the calculator. So this is the exact answer. I'm gonna see what the decimal is. So this is gonna be negative 33 divided by 2 term in the denominator. I'm dividing, so put it in the parenthesis. 9 minus 2 times natural log of 4. Close parenthesis for natural log of 4. Close parenthesis for my denominator. 2 decimal place will put me at negative 5.30. Alright, that's how we do this one. Slightly different type of problem compared to the one on the left. Now, all these problems up here are 2 terms. Okay, all these exponential equations here are 2 terms. This particular exponential equation involving with 3 terms, so this one will work differently than all the previous ones. Cannot take a natural log. Okay, cannot just simply take a natural log trying to get rid of my e. Okay, that's actually not going to work in this case. Alright, because we normally take a natural log on both sides when we only have 2 terms. So you can't do this, take a natural log in every term right off the bat, because right away you will take a natural log over 0 here, which is actually undefined. So how do we go about doing this problem? This problem is actually what we so-called quadratic in form. Okay, let me show you what that means. This is another technique, okay, that I don't know if you've seen this before or not, called a substitution method, called a U-sub. Alright, the way how the U substitution work is let another variable U to represent something in your equation. Okay, and it turns out that this problem is quadratic in form. That means this problem looks like a quadratic equation. So I'm going to let my U represent e to the x. Okay, now U represent e to the x. Here is the reason why. Take a look at this e to the 2x. Okay, e to the 2x can be written as e to the 2x whole thing to the first power. You can write this as e to the first power whole thing to the 2x power. You can write this as e squared whole thing to the x power. Okay, all using idea of a power rule. Or you can look at this as e to the x whole thing squared. Okay, so because I can write e to the 2x as e to the x whole thing squared, that means this e to the 2x is going to be e to the x whole thing squared like this, minus 4 times, okay, just e to the x to the first power, and then minus 12. So this is quadratic in form because the exponent for a quadratic equation says 2, 1, 0 power. So all these e to the x is going to become another variable called u. So by using U substitution method, I can rewrite this whole equation as u squared minus 4u minus 12 equal to 0. Now I can solve for u. I can do it by factoring, I believe. U and u, 2 and 6. Last term is negative, so my choice is 1 positive, 1 negative. Gotta be negative 6 on the altar, positive 2 in the middle to give me negative 4 here. Alright, set each factor equal to 0. My u is equal to negative 2. My u is equal to 6. But remember now, this problem we're not solving for u, we are solving for what? For x. So once I got my u by itself, I can go back and say every u I got right now represent e to the x. So rewrite u equal to negative 2 as e to the x equal to negative 2, and e to the x equal to natural log, equal to 6. Alright, now we can solve for x. Alright, they want the exact answer here. So now I got 2 terms. I can now take a natural log on both sides. Alright, natural log and e will cancel out. Okay, so x is equal to natural log of negative 2. And as you can recall, we can never take a natural log of a negative, so this cannot be my answer. Same thing with this one here, natural log take a natural log on both sides. So my answer, x equals natural log of 6. Okay, that will be my answer. Alright, in next video of 5.5, I'm going to show you how to solve logarithm equations. Thank you for watching.